Hello guys, it's Peter here, Piotr Fistner. How are you doing, guys? So, in today's episode, we will be switching to the photos, and we will talk about the induction oven. Is this one? No. Okay, so again, same story here, but we will start off the first one. If it's too noisy, I won't post it. If it's quite okay, I will post this video. The fan noise is from the new inverter I bought, and it's pathetic. I can't use any other word to this, just pathetic. Don't buy cheap inverters or build them yourself if you are capable of, or buy dear inverter with toroidal transformer, or complain after, as I'm complaining now, and I need to redesign it now. But okay, back to the story. So what it is this is an induction oven. This is a Siemens, and here is this is a top part, and it's showing E1. So I've checked. E1 error means internal error. It can be either something loose or one of the boards should go faulty. So what I did here at the ground is you can see those plates, which are induction coils, yes, and here is the electronic for each of them. Now, what I found was that this part was different from the readings of those two, because here is the input of the mains 1, 2, and 3. They are 3 cables connected together and connected to 240 volts in the mains. Now, this pass current, no problem, yes, throughout the board. And on this bridge rectifier, you can have like 16 or 18. On this one, you've got 16 or 18. So, you know, it's quite similar. It was a bit too much difference, but because the design of those two is slightly odd, I said, oh, okay, let's say it's okay, yes? So I went to this one, and guess what? On this green bridge rectifier, yes, on this one, I don't know if we can't zoom in. Okay, we can. So on this green one, bridge rectifier, I found 0, and on the input and on the output side. So I said, okay, so we've got 246 or 8 volts here, and we don't have anything here. Weird. And we've got on the rest, suspicious. So let me look what's from this point to this point can be faulty. Yes, so what I did is that I took out this main board, or Pavo, I don't remember who, me or him, and I start to measure. That's the back of the board, and let's focus onto this side on the photo, to this top 254 GN, yes, chip. Now this one is a small bridge rectifier, which you can see as well here somewhere. Oh, here, that's this small fella, yes, here. So this bridge rectifier receives a power, so you can see 246 or 8 here, and on the output about 380, 90 volts, something like that, yes. So then when you flip the board, you can see, okay, let's go to that magnification photo. Then you can see that the opto-isolator, because that's the bridge rectifier, which goes straight to this chip, yes. And then what's happening is that, okay, fine, we've got a voltage, we're happy chappies. So why this don't give anything onto the transformer, this yellow black transformer, yes. So this is only going through this pin, straight away from this pin. It should give something, yes. Then I said, okay, maybe the opto-isolator, but it turns out that 4.4 volt and 1.1 volt, so, and the diode and the phototransistor are working, yes, inside it. So I said, okay, no problem. So the culprit is this top. So that's what I wanted to show you guys. I don't know where I am. Here. So that's the diagnosis I've made till now. I've ordered those tops. And if this won't work, I'll make another video and I will explain you further steps what I will find as an issue. Fingers crossed that's only this top. I've ordered 5 them. They were available on Mozart. So I've ordered it. It should come within the next 5 days. And if it will work, I won't record any more videos about it. If it will be further issue, I will record. Because the question is, I didn't want to put, because I could put 15 volts or something, yes, on the output. See the top 254 GN, what is the voltage on the output, and I could put it. I could, but they didn't want to because it's not professional. I'd rather replace component which I know, because what if there's some PWM which I haven't noticed and I will just make something faulty. Why it's so? Because we've got a transformer, yes, so digital to analog. It's done on that chip, and then I would have to know how many hertz, etc, etc, because that's a high frequency transformer. So again, I could use any other chip we use in the inverters, for instance. Yes, I could, and I could set up dead zone and the frequency, but that way we know we done everything correctly and we don't cause further damage to the device. Plus, this is the case where a customer has a stone, either granite or something, and it's cut it for that particular Siemens hub, yes, induction hub. And the problem is that now they would have to cut this granite in order to get another one fitted, because none of the ones which they check in the shop can fit it. So it is a huge problem for the customer. So if we can fix it, that saves a lot of hassle, and for sure cost on top of that. Yes, so fingers crossed it's only the component faulty and we won't see any further issues. That's it in this video. Thank you for watching. Hope you've learned something, how I work and how I diagnose electronics for commercial customers, because that's for the commercial customer, that's not for the end customer of this induction oven. I don't do repairs of white appliances. I only do PCB repairs, and that's a PCB pretty much. So I wouldn't go to the customer, I wouldn't dismount it, I wouldn't bring it to my repair shop or diagnose it there, no. But I could fix the PCB, what I see as an issue, and that's why you see it. Thank you for watching again. If possible, let's fix them all, and see you in the next video.